Hello everybody, this is AYDENandDAD, and
today we're going to show you the Wilros Arduino sketch number 2.
So today we're just going to add a potentiometer to our previous project. You'll need everything you need for the previous project, which is 3 cables, an LED, a resistor, and then another 3 cables, and a variable resistor. So 6 cables total. Right, so a couple things you'll notice. One, we've moved this circuit up on the breadboard, and we're not plugged in to the computer. Those are 2 important things. We moved this up because if we didn't, it would be very crowded down here. So, first step. Plug the variable resistor in along anywhere really, but there will do. You just have to make sure the 3 pins are on the E track. It just makes it slightly easier for us. Then you're gonna take, doesn't really matter which cable, but I like color coding. So, orange cable, plug it in on, the far side, the closest to the LED. And then, this next bit, very important, plug it in on the positive bus. This is now our positive cable, like this red one. Then the green one, or the slightly longer one. Plug this in the middle, and then plug this in on the board. I'm sitting. Then plug this in, well, you'll just see it's hard to point to, but that one. Plug it into A0. Then, the blue one, or the last one, farthest away from the LED. And this is going to be plugged into your negative bus. And that's the circuit constructed. What to do on the computer bit. Right, so, first you're gonna go up to this middle button, click open, go down to the USK guide code, and then circuit 2.
Okay guys, so you'll see the new stuff here is this integer lines. So that's a definition of a variable and a value assignment to a variable. But you'll notice it's outside of our loops. Let me just show you. Here's our setup loop here, and here's our main loop here. And it's outside of that, it's on top of that, above it. This means these are global variables. But let's first go through them, and then I'll explain to you what a global variable is. This is our sensor pin assignment. You'll remember Aiden plugged this into A0. Now this is the 0. This is analog pin 0's number. This is just a type, so it tells you this variable is of type integer and its value is 0. Similarly, instead of using the 13, you'll remember from the previous video, we used 13 for the digital pin. Now we're going to assign that to a variable, just to show you how to use variables in a sketch like this. The name of the variable is LED pin, and as always, remember this case is very important, so if you put a capital P there, you've got to use it like that throughout your program. Otherwise, it's a different variable. And same thing here. Type integer. It has a value of 13 and its name is LED pin. Now let's see how these are used. Oh, and the reason why they're global, in this case it's just for illustration purposes, to teach you something, but a global variable can be used in all these loops down below. If you define the variable inside this loop here, in this setup loop, which ends here, starts there. If you define it in here, then it would only be usable inside this loop. You would not even be able to see it in this loop. You won't be able to use it here. So you can use 2 variables with the same name, one there and one here, and they would be 2 different variables if you haven't defined it globally like this. Okay, let's look at our setup loop. Inside here you'll see there's only a single line. Just like in the previous one, in this case it's our digital pin, which we created a variable LED pin for, LED pin, and that one's value is 13, if you recall from there. So you'll see this command is exactly the same as in the previous sketch, this used to be 13, but now we replaced it with a variable, and that variable's value is now 13. So again, this changes the specific pin, pin 13. It's a digital pin. It's changing its direction or mode, if you will, to output instead of input. Let's go down to the main loop here. That's just the beginning. I'm going to scroll that off so you see the ending there. Okay, let's do it like this. Now here's a local variable. This is not a global one because it's defined only in this loop, as you can see, and it's called sensor value, and it's an integer, but you'll see there's no assignment this time. Now right here is where we're going to assign it. You'll see it's being used here on the left hand side of the equation of the assignment operator, if you will. That's what that is really. And it does a new command, analog read. It means read from an analog pin. And which pin? Remember we made this variable's value 0 up here. So it's going to read in from analog pin 0, and the value that it gets is going to be assigned to this variable sensor value. Now let's quickly talk about the difference between digital and analog pins. A digital pin can only have two values, on or off, a 0 or a 1, a high or a low. And you'll remember from, you can even see it here, there we set it high. This is a digital pin, the lead pin, and it's also called digital write. We set it high voltage, 5 volts, meaning on, and here we bring it low, so we make it 0 volts, and we turn it off basically. But the analog pin can have a value between 0 and 123, so 124 possible values. Depending on what we're going to turn that knob to, we're going to get either we're going to get a value between 0 and 123, which we're going to read into this variable here, sensor value. And you'll see, instead of using the 1000 like in the previous sketch, which is 1000 milliseconds, which is 1 second, now we're going to delay depending on what we turn that knob to. If we turn it very low, it's going to read a number like 1, 2, or 3, or 10, or something like that. So this delay is going to be very short, because it's only going to be 10 milliseconds, for instance. It's going to turn the layer on here before that, then delay for 10 milliseconds, then we turn it off again here. And this value, which hasn't changed, because we haven't turned the knob yet, it's going to be still 10, so it's going to be delaying it for 10 milliseconds again. And then it's going to loop around, and if in that time we changed the knob, we turned it up high to, let's say, 500, then it's going to read that 500 in from the analog pin here into the variable sensor value. We're going to turn the LED up higher, we're going to turn it on basically, delay for that 500 milliseconds, switch it off, delay for 500 milliseconds, and go through again.
Right, so now that it's plugged in, we're going to go verify, and this green bar of friendliness will fill up. And when this white text appears, we click the upload button. And if we watch the board, it goes beeping. And if I spin this toggly bit, this wheel thing, you'll see that it'll blink faster. It's a marvel of engineering.
What's important here, guys, is to realize that this is a totally separate circuit. The LED is on its own circuit here, but we got its own supply for the pot or the potentiometer. And the only thing we do is we take this line off of the middle pin, which reads the variance in the resistance that we caused by turning that knob. and give it as an input on this digital pin there. And then our program, our sketch, does the rest of combining the two circuits to give us one effect.
So in this video, we showed you how to implement a variable resistor in your projects. If you like this video, don't forget to like, favorite, and subscribe. Thanks for watching. Bye!
Bye.